Hello, everyone. Let's take a look at this LeetCode problem. It's the last problem in the biweekly context, and it's a hard problem. Although it's a hard problem, but after we analyze this problem, it may be not that hard. Okay, let's take a look at it. If you haven't read the problem, you can take some time to read it. We can just start with example 1. In example 1, batch size is 3, which means we will make 3 donuts every time. This is the best answer after rearrangement. So at first, there's a group of 6 people. Then we can make 2 batches, each is 3, so the 6 people can consume those donuts and there's no remaining donut. Next, there's a group of 2 people. So they can have the fresh donut, then there is 1 donut remain. Next, we have group of 4. Since there's 1 donut remains, so this group cannot eat the fresh donut. The first people will eat the remaining donut. Then we make another batch. The remaining 3 people have the 3 donut. Next, there's a group of 5 people. They all can have fresh donut. Then there's 1 remain. Next, there's a group of 1. These people just eat the remaining donut. At last, we have a group of 3. Those people can have fresh donut. Okay, then we find that it's always a good idea to put like a number that can mode batch size is 0. For example, the 6 people, they can eat all the donut and there's no remain. So it's always a good idea to put the numbers that mostly is 0 like at front. Also, it's also a good idea to like to put like a 2 group of people that their sum mode batch size is 0 together. For example, 2 and 4. 2 plus 4 is 6. 6 mode batch size is 0. 5 plus 1 is 6. 6 mode batch size is 0. It's always a good idea to put either a single number such mode batch size is 0 to front. And it's always a good idea to put 2 group of people that their sum is like most batch size is 0, like to the front. So, and there's also a tricky idea here is that, for example, batch size is 4, like 5 mod 4 is 1, 9 mod 4 is 1, 13 mod 4 is 1. It's the same effect to have a group of 5 people, 9 people, 13 people, 1 people, since the mode is always 1. So that we can have code like this. If the group of people mode batch size is 0, we can just increase our result. Otherwise, we can pick like 2 group of people that their sum is like mode batch size is 0, like here. For this group of people with mode batch size, we get G. If counts batch size minus G is greater than 0, we can just use that. For example, 1 and 3, 2 and 2. Then we can increment our result by 1 and consume batch size minus G. Otherwise, we just increment counts G. So after this initial process, we know batch size is 4, and this is our initial groups. After the process, count is 0, 2, 0, 0, result is 3 now. Okay, so now we have counts. So we need to further process the counts. The counts meaning like how many groups like their people like mode batch size is 1. So 0, 0. For 1, we have 2 groups. For 2, we have 0 group. For 3, we have 0 groups. Next, we need to process the counts to get our final answer. So count the result is our partial answer. We also need to process these counts. For processing the counts, we need to backtracking. Since we don't know, like there are so many groups in these counts, we don't know like if we should group like 3 such group together or 4 such group together. We cannot use greedy approach here. So we need to use backtracking to process it. So each time we just for loop from 1 to like the size. Like every time we can use it or not. So we have so many choices. We need to try all possible combinations. So every time if const I is greater than 0, we will try to use this group. So if const remain is 0, we will initialize temp to 1, otherwise it's 0. Since if const remain is 0, and we use this group must be happy group since there is no remain. Now we use this group, so const I minus minus, then we DFS recursively process it. And don't forget to restore the state. Since we decrease the const I, we need to increase it again. So in this DFF function, we pass const, and we need to update remain here. Since this group, the I group, they will eat some donuts, so we will update remain here. Okay, at last, we just update our result. Finally, we just return this result. This function means for count counts, like given count remain, and how many happy groups are there. Okay, it works, but it's a little bit slow since there are many duplicated subproblems. For example, if this is our count, like at first we pick a group that has 1 people, then we pick a group that has 2 people, then counts become 0, 2, 1, 1. Or we can first pick a group that has 2 people, then pick a group that only has 1 people. Count is still 0, 2, 1, 1. So there are many duplicated subproblems. But those subproblems, they have same state. For example, counts are same. So we can just construct a key from this count. There are many ways. For example, we can construct a key like this. For group of 1 people, we have 2. For group of 2 people, we have 1. For group of 3 people, we have 1. So this is our get key function. We just generate keys from our counts. We just for loop from 1 to last, since there is no meaning to start from 0, since it's always 0. So we will just generate key like this. Okay, then we add a cache to our backtracking function. We have a cache, it's a hash map. The key is string, the value is an integer. Okay, so we first generate this key, and if the key is already in our cache, we just return the answer. Otherwise, we do the calculation for our current state and update our cache. Okay, that's our final answer, and you can pass the test cases. Okay, so there's just 2 main components here. The first one is the pre-process. We know that the value of each group can be very large, like 1 million, but there's no meaning to be that large since batch size is only at most 9. And we know if batch size is 4, then like 1, 5, 9, 13, they all have the same effect. So we don't need a large number. We can just mode batch size. And we just greedily, like, if G is 0, we can just increment our result. If there are 2 groups that their sum is like mode batch size is 0, we can also just consume them first and increment our answer. Then after this pre-processing, we have the counts vector. And we need to use backtracking to process this counts vector to get the result. Okay, see you next time.